I am Dr. Omar Zakaria and I am pleased to welcome you back to this new segment of our Algebra 1 course designed for first year preparatory class students at the École Nationale Polytechnique de Constantine. Today we will delve into some fundamental concepts of Algebra 1 that needed in your academic journey. Chapter contains four essential parts, which are propositional logic, proof techniques, sets, and applications. Throughout this course, students will study the fundamental of logic and rules of inference, which are essential for developing rigorous mathematical reasoning. This includes understanding propositional logic, continuous proofs, and deduction techniques, all of which play a crucial role in algebra and other mathematical disciplines. Also, students will gain a deep understanding of key algebraic structures such as sets and application. We start by the notion of propositional logic. Propositional logic, also called statement logic, that deals with the study of logical relationship between propositions. A logical proposition, or simply proposition, is a declarative statement that can either be true or false, but not at the same time. Proposition can be combined using logical operators to get more complex logical statements. The major part of mathematical logic is understanding how to rigorously prove or disprove a statement. As you see, we have the basic proof or techniques or strategies like direct proof. In direct proof, we prove a statement by straightforward reasoning. We have also proof by contradiction. In proof by contradiction, we assume the opposite of what you want to prove and deriving a contradiction. And we have also proof by contraposition, proving the contrapositive of statement, and proof by induction, a method of proving statements about integers or other well-ordered sets by showing the whole for the base case and that is the whole for an arbitrary case n, they hold for n plus 1. We have existential proof. To prove the existence of something, it's necessary to explicitly show an example. So to give this existence. Universal proof is to prove something is true for all elements in a set or in a range. Prove it for an arbitrary element in that set. Now we move to another important part in this course, which is sets. Sets are one of the very most basic and essential structures in mathematics, forming the foundation of algebra. A set is a well-defined collection of distinct objects called elements and we introduce some basics like union, intersection between sets, and difference between sets, and also complement of sets. After that, we discuss the application. An application defined on sets is a rule that assigns each element of the set called image sets called the domain to exactly one element of another set called the codomain. The direct image of a set by an application is the set of all outputs values that takes when applied to the element of that set. The inverse image or pre-image of the set under an application is the set of all elements in the domain that map to the set. Application between sets can be classified into three main types based on how elements are mapped. We have first type is injective application. An injective mapping or application if distinct inputs map to distinct outputs, and this figure explains what I have said. Surjective if every element in the codomain is mapped to by at least one element in the domain, and bijective if it is both injective and surjective. So by mastering these core topics, students will develop essential problem solving skills, logical reasoning abilities, and computational techniques that are necessary for both academic and real-world application. Thank you for your attention.